Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 16 of Azure Zero to Hero series, and this video is very important from the interviews point of view. Why? Let me explain. So in the last class, we implemented continuous integration and continuous delivery and deployed microservice architecture application onto the AKS cluster, which is very good. We used Azure pipelines for the CI and we used Argo CD for the CD and deployed the microservice application onto AKS. Along with that, we learned how to create AKS cluster. We learned how to configure virtual machine scale sets as node pools to AKS. We also did good amount of hands-on, which is good, right? But did you think why not we use a self-managed Kubernetes cluster in the same project? We used AKS, which is Azure Kubernetes Service. We went to that particular service, something like this, and we clicked on the create button, provided bunch of options, and we got a Kubernetes cluster. But as a DevOps engineer, we can also create virtual machines and install the Kubernetes platform on top of that virtual machines or the services on top of the virtual machines. We can also create a self-managed Kubernetes cluster, right? So why did we not use that? Is there any difference between AKS and self-managed Kubernetes clusters? When someone asks you in the interviews, should you say AKS or should you talk about self-managed Kubernetes clusters? This is what we are going to learn in today's video. In the last class, we did hands-on on AKS. In next class, we will do one more hands-on project on AKS. So we will be doing a lot of hands-on, but this is something that you need to understand and explain in your interviews. So let me do that. Let's go to the whiteboard and firstly understand if there is a DevOps engineer who is working on Azure, what are the different ways that a DevOps engineer can create a Kubernetes cluster, right? There are three ways effectively. Number one is, of course, the organization. Let's call this organization as example.com. So, of course, the organization example.com is completely on Azure, but they might also have on-premise environment, right? So the first method the DevOps engineers can create a Kubernetes cluster is completely on premises, where if they have a data center, right? So if they have some physical servers, so using some virtualization platform or using some private cloud platform like OpenStack, which is quite popular. So they can create bunch of virtual machines. Let's say they create 5 virtual machines and 3 virtual machines they use for the Kubernetes control plane and 2 virtual machines they can use for the Kubernetes data plane. I'm not explaining what is control plane, what is data plane, what is Kubernetes architecture, because we have a dedicated Kubernetes playlist and this is all covered in the DevOps Zero to Hero series. If you are finding these concepts difficult, then you can check our Kubernetes playlist, or you can also check our DevOps Zero to Hero playlist. So I'm assuming you have some knowledge on Kubernetes at this point of time. So this is one way of creating, where the control plane or the master nodes, right? They can be created on 3 node architecture, and 2 nodes can be used for the worker node or for the data plane. So this is one way of doing. Second way is on the Azure platform, right? On the Azure cloud, the DevOps engineers can go to the virtual machine service. So, and request for 5 virtual machines on the virtual machine service. So you get 5 resources. Similarly, even here, what the DevOps engineer can do, once the DevOps engineers get 5 virtual machines, they can use these 3 virtual machines for control plane. Let me call it as CP, and 2 virtual machines for data plane. That is master and worker nodes. Again, why I'm talking about 3 nodes for control plane? Basically because we can set up high availability, minimum with the 3 nodes. So that's why, and this is a recommended practice also. Probably this is the second way how a DevOps engineer can create a Kubernetes cluster. So on the control plane, a DevOps engineer will install all the control plane components, and on the data plane, DevOps engineer will install the data plane components of Kubernetes. And there is a third way where DevOps engineers can go to AKS service, Azure Kubernetes service, which we did in the last class, this particular thing, and request for a Kubernetes cluster. Typically in this case, DevOps engineer just has to provide the name, some more fields, plus what is the node pool, which is virtual machine scale sets, and DevOps engineer gets their Kubernetes cluster. So there are 3 ways, right? This is option 1, this is option 2, and this is option 3. Both option 1 and option 2 are self-managed Kubernetes clusters. These are self-managed KX clusters, and this is Azure managed Kubernetes cluster because you got it from the AKS service. And here, in this case, Azure performs some management, maintenance, some of the activities for us, which I'll talk about in a while. So this is Azure managed KX, right? So this is self-managed, both of these options. One is on-premises, everything is on-premise, where in the on-premises data center or on the private cloud, which is set up using OpenStack, the DevOps engineers can spin up some virtual machines and install the control plane and data plane of Kubernetes. So this is the self-managed. And similarly, even on the Azure platform, you can create a self-managed Kubernetes cluster by spinning up some virtual machines through the virtual machine service. And finally, the not self-managed way, Azure Kubernetes cluster can also be created using the AKS service. So now, when should you go with these options and when should you go with these options? First of all, let's understand the pros and cons, right? Before I tell you, you should go with this option, you should go with this option. Let's try to understand the pros and cons of 3 options. So there are bunch of parameters which I'll take into account to explain the pros and cons. So the first one is on-premises. The second one is, let me call this as virtual machines K8s, just for easy writing. And final one is AKS. So the first parameter that I would like to discuss is the maintenance. Ignore the spellings, right? So the first parameter that I would like to consider is maintenance. So if you are using a on-premises environment, and if you try to manage the Kubernetes cluster by your own, then there will be a lot of maintenance. Creation of Kubernetes cluster, I'll not take into account itself, because in the world of infrastructure as code, creation, writing the scripts is just one-time activity. So here, in case of AKS, you can just click bunch of buttons, but I will not consider that as an advantage over the other options, because today we are in the world of AKS like Terraform, or even here you can also use Azure Resource Manager scripts. Using these IAC tools, if you just write script once, from next time it's just execution of the scripts. So creation of a Kubernetes cluster is easy using AKS. I wouldn't consider that point. Considering Terraform or any Python, any particular libraries can easily create a Kubernetes cluster for us. It's just one-time activity to write the scripts. From next time, you can just run the script and the Kubernetes cluster will be done. But here, the maintenance activities that I'm talking about is one, upgrades. You install today, let's say you installed 1.27 version of Kubernetes cluster. Tomorrow, there will be a new patch that is released. Let's say you are installing 1.27.4, and tomorrow there is a new version of Kubernetes that is addressing a very critical vulnerability, and Kubernetes team has released 1.27, let's say 1.6 or 1.27.8 they have released after 1 month. So you need to upgrade to this version. Or sometimes you are on 1.27 and you have been using this cluster for 1 year. Kubernetes typically releases once in a quarter. So, or 3 times a year. So if you are using this cluster for 1 year, then probably the new version of Kubernetes is 1.30 and you are still on 1.27 version of the cluster because you are not performing the upgrades. And this version is out of support, which is an obsolete version, which is also not a good thing. So if you are setting up a Kubernetes cluster on your on-premises environment, you have to do maintenance with respect to upgrades. You have to timely upgrade to the, typically in industry, there is Extreme, Y stream, and Z stream, also called as subminor version, minor version, and major version. So if you are talking about 1.27.4, then this is called as Z stream or subminor version. This is called as Y stream or minor version. This is called as extreme. Usually people don't call it as extreme, but call it as minor version, right? So if you are using your own version of the Kubernetes cluster where you are setting up this entire thing on premises, then the challenge is that once in a while you get Z-stream upgrades from Kubernetes and you also get the minor version upgrades, that is Y and Z streams. You have to perform these upgrades by your own. This is one disadvantage you can consider. And along with that, not just the Kubernetes upgrades, right? When you are creating virtual machines, let's say you created a virtual machine and this virtual machine is set up with CentOS 8.1. Just giving an example, don't take this too literal. So after a while, even this version gets upgraded, right? CentOS version also gets upgraded. There can be CVEs, that is vulnerabilities on the CentOS operating distribution as well. So you also have to timely catch up with those upgrades. So the first upgrade I was talking about was the Kubernetes version upgrade. The second upgrade I was talking about is the node upgrade. So these kind of maintenance activities you have if you are setting up on premises. Whereas in this case, that is Azure Virtual Machines K8 clusters, it is exactly same. Probably you will get some effort less here if you are using virtual machine. Some of them will be upgraded by the Azure platform, but you cannot skip this one. You need to upgrade your Kubernetes cluster by yourself. Whereas if you talk about AKS, you have some freedom here because in the AKS, while you are creating a cluster, let me click on create and show you. So if you use this option and scroll down a bit, you will see this option called as automatic upgrade. And in the automatic upgrade, while creating a Kubernetes cluster, initially you will set up a particular version, right? Let's say I go with 1.27.7 today, and I can enable this option enabled with patch. That is, Kubernetes will make any updates the cluster to the latest patch version within the set minor version. So it is not upgrading the minor version, but it is upgrading the patch version. Patch version is nothing but Z-stream version or the subminor version. So tomorrow, if there is something like 1.27.10, which is addressing a critical vulnerability, then Azure will automatically upgrade this version if you set this option, right? And you can also set up automatic upgrade scheduler. Like usually if you don't work on the Sundays, your organization does not receive traffic over Sundays, you can set up this option every week on Sunday, or you can set up first of every month, first Sunday of every month, depending upon how frequently you want to upgrade your Kubernetes cluster. It is very important that you timely upgrade, because if you are not upgrading it and if there is any critical vulnerability, then you will end up with some security issues on your Kubernetes cluster. But end of the day, what I wanted to say is if you are going with AKS, the advantage that you get is less maintenance. Of course, don't think that I'll be only talking about the pros of AKS. There are cons as well, there are disadvantages as well, which I'll be talking about. Second thing which I would like to talk And there is no order of priority. Whatever I'm talking about, don't think that this is first important topic. I'm just bringing up in random order. Second thing is cost. For organizations, cost is also very important. So I will talk about this. If you're talking about cost, now this is very interesting one to discuss because when you are at your on-premises environment, sometimes you already have your on-premise infrastructure and nobody is using that on-premise infrastructure. Possibly your organization completely moved to cloud, but you have that on-premises environment for a while and nobody is using it. If you set up your Kubernetes cluster in such cases, you have your data center and there are resources left on your data center. So you are using them for your Kubernetes cluster, then technically, your cost will be very less. But if you don't have your on-premises environment, you are just buying the servers, setting up the data center, everything for just creating this Kubernetes clusters, then your cost will go very high because you have to maintain that entire thing. There has to be system administrators and all the team for that. In this case, the cost is actually moderate. I cannot say that cost is too high or too low because it depends on how you are managing. Typically, what is your cost optimization technique that you are using in your organization? How effectively are you using the virtual machines? Here you are requesting virtual machines from the Azure Virtual Machine Service. So are you requesting for the right size? Do you have auto scaling setup? And is your auto scaling in a right way? What are the configurations that are around your virtual machine? So there are so many factors. And if you don't have cost optimization in place, then you will be charged for the virtual machines, storage, whether you are using it or not using it. As you request from Azure platform, you will waste those resources if you're not using them properly. So here I will leave it up to the cost optimization of the organization. Third thing, AKS. So in AKS, you have some advantage here because AKS will only charge you as per the thing that you are using. Unlike in this case, where you are pre-requesting for particular set of resources, right? You are defining that, okay, this is how my entire virtual machine storage should look like, virtual machine resources should look like. On the contrary, if you are using AKS, the control plane, to be very specific, AKS comes with managed control plane. That is all the control plane components of Kubernetes, such as API server, you have etcd, you have the scheduler component, controller manager, cloud controller manager. You have a bunch of components, right? These are the services that are part of the control plane. So these things are managed by AKS, that is Azure Kubernetes Service, and you don't have control over the control plane components. So these things will be cost effective for you, but otherwise the virtual machine scale sets that you're using for your data plane, like we used in the last class, right? If you go to the node pool section, so here also we use the node pools for the data plane and for some system workloads. So with respect to the control plane, you might see some cost efficiency because Azure manages it effectively for you. Then the next option, towards the end of this video, I will tell you which one to also talk about if you are working in an organization or if you are not working and planning to switch towards the DevOps stream, then I'll also pick up one option for you. Then the next parameter that I would like to talk about, like we discussed about maintenance, we discussed about cost. Then let's talk about scaling. Scaling or availability, scalability or availability. Very, very important, right? Because let's say your applications are receiving more traffic, right? In this case, in the AKS, we have configured node pools, right? So in the node pools, we clearly mentioned that the node count should be initially 2, but if there is more traffic, you can also scale the nodes up to 5. So here we are using virtual machine scale sets. So there is the auto scaling feature that is enabled, and this auto scaling will make sure that my Kubernetes cluster is scalable and available. And AKS also helps you with respective setting up this auto scaling automatically, right? If you are configuring the virtual machine scale sets, depending upon the traffic, the nodes are scaled automatically. Here, when you are doing it on premises, unless you have some softwares installed out of the box, most of these on premises softwares do not come up with auto scaling. If you are installing some packages, it's a different case. I'm not talking about those cases, but out of the box, you need to manage your scalability and availability by your own. You have to make sure that your Kubernetes cluster is rightly responding to the traffic. If required, you have to scale up and scale down. In this case, again, if you are creating the Kubernetes cluster on the virtual machine, you have to manually take care of your scaling, or you have to make sure the auto scaling configuration is in place. I'm not saying you cannot do this in this case, you can do it, but you have to make sure the configuration is set. In this case, it's slightly difficult. Number 4. So we discussed about maintenance, we discussed about cost, we discussed about scalability. Then one more important aspect, after working a lot on the Kubernetes, I've been using Kubernetes from last 7-8 years. To be honest, to be specific, I think 2016. So yeah, almost 8 years now. Integration is one of the most important aspects as a Kubernetes kept growing, right? Previously, Kubernetes was just about pods, deployments, and services. But eventually, now you have a lot of integrations with Kubernetes, such as you have your ingress, you have your CSI drivers, you have your secret management solutions. So there are a lot of things that you need to do with Kubernetes, right? If you are doing it with on-premises, you have to take care of all of these configurations by your own, and integrations are not straightforward. So I'll give you a basic example. If you are working on premises, you cannot create a load balancer service. Of course, there is some project called MetaLB where this is not completely production ready, but out of the box, you cannot set up a load balancer type service on the on premises because the cloud controller manager component does not work on the on premises K8s clusters. Here, you can do uh, the integrations, but you have to make sure all the integrations are in place, which is not at all easy. Let's say you want to connect the virtual machine setup Kubernetes clusters with a secrets management solution on AKS, or you want to set up a, CSI driver configuration where you want to use some storage, right? It's not that easy in this case. Even the Azure Active Directory setup and configuration is not that easy. In this case, it's much easier. Okay, but what are the disadvantages? If you are using AKS, I'll not say disadvantages, but disadvantages compared to the option, let's say on premises, right? Or let's say this option. One is security. So how is security a disadvantage? If you're using on premises, right, you are on your private cloud. So you have lot of control over your private cloud, and this is typically set up in your own data center. Whereas if you're going with AKS, then you have set up your Kubernetes cluster. Of course, you might have the VNet configuration, the virtual private cloud configuration, but it's still a public cloud, and you have to make sure all. I'll give a best example. Probably you want to run a database, and you have some very critical user information. So still a lot of companies might want to store their data on the on premises. So they might end up using the pods, running the pods, everything on the AKS cluster here, but running the data on the on premises and somehow managing the connection between the pods and the database volumes that is available on the on premises environment. This is one case. Additionally, if you're on your on premises, you get very good firewall control, right? You can set up any level of additional security on your on premises environment because this is completely in your control. And additionally, you have things like too much flexibility or too much customizations because the control plane is managed by AKS. So you cannot make too much flexibility or customizations to your control plane. So these are some of the disadvantages that we get with AKS as well. Now, talking about the most important thing, okay, Abhishek, we have compared different parameters. We compared maintenance, cost, scaling, integration, security. We compared about flexibility and customizations. What about during the interviews? Should I explain that we are using on-premises virtual machines, that's the self-managed Kubernetes cluster on Azure, or should I talk about AKS? So here it is very simple. AKS is a very easy thing if you would like to do it. So if you are beginner to Kubernetes, you don't know too much about the creation of the Kubernetes cluster, you are not too much into Kubernetes cluster upgrades, of course you should learn that. But if you are a beginner and if you are not too much experienced with Kubernetes, so you can learn the fundamentals of the Kubernetes, create resources, deploy resources, learn about ingress and all of these things. And then you can talk about AKS. So you can mention during your interviews that you are using AKS and this is how you are managing the Kubernetes clusters in your organizations. Secondly, if you are working for a startup, most likely your organization might be using AKS because for startups, it's very easy uh, for them to run with less resources. I'm talking about less number of people. So if they are managing this entire things by their own, if they are doing on premises or if they are doing Kubernetes on top of virtual machines and managing the entire things by their own, they might need more number of DevOps engineers for upgrades, for scaling, for patching. So again, for startups, they will go with the AKS option. So in both of these cases, it's better you talk about AKS. Alternatively, let's say you are experienced person, you're working in MNCs and you have good exposure towards upgrades, you have good exposure towards scaling, creating Kubernetes clusters using Terraform, then you can go with the Azure Virtual Machines K8s. And if you know all of these concepts, then it will help you more during your interviews. Even if someone asks you about the upgrade process, if they ask you about the cost optimization techniques, then you can talk more about these things. Most likely, the organizations which have been there for a long time, they will be using this option because AKS was not there from a long time. So initially, if they have been on Azure from a long time, then this is the option they would be using. Now, on premises, don't talk about this unless you have real on premises exposure and your organization is really on premises. Because these days, everybody is moving towards cloud. There are few exceptions. There are few organizations that are coming back from cloud to on premises, but mostly organizations are on private cloud. So unless the JD mentions anything about on premises, I will prefer not talking about the on premises. Or if you have good experience, you can talk about it. So this is about the video, and there are multiple other things which I did not cover. I know, like for example, setting up the container network interface or configuring the advanced CNIs like Flannel, Calico. I did not talk about all of these things. They are additionally included if you are using on premises or Azure on the virtual machines. So these are some of the things, the major things that I have covered, and I hope this will help you in deciding which one you should use. And please watch the previous video, the Azure DevOps CI/CD. We have deployed resources to AKS. And in the next class, we will also learn about all the important things such as deployments, services, ingress, ingress controller, so that you can also talk about AKS during your interviews. See you all in the next video. Thank you so much. Take care.